potassium, carbon, just minerals that flow in from streams. I'll just throw in through the environment. Magnesium, calcium, sodium, all sorts of things. Okay. So eutrophic waters are going to be poorer, lower in dissolved oxygen, and that's going to be more of the Centrarchidae family, or the sunfish family here. That's bass, largemouth bass, bluegills, brim. The Centrarchid family is a northern hemisphere equivalent of the Cichlidae family, south of the hemisphere, which has a lot of tropical fish. We'll talk about that later in the lecture. Okay, and oligotrophic waters are going to contain a lot more dissolved oxygen, and they're going to be waters of trout, things like that, fish that need a lot of oxygen, and mountain streams, very, very cool streams. Next, we talk about aquifers. I mentioned that earlier. An aquifer is a large underground source of fresh water. For example, now the Southern California aquifer is drying up. Takes millions, and it's almost, think about it almost like drilling for oil. It takes millions and millions of years for the oil to build up. When we first discovered oil in this country, it was in Pennsylvania, huge reserves. Then it was down in East Texas. Again, it was almost like an aquifer full of oil down there. It takes hundreds of millions of years to get that way. And it can take millions and millions of years for water to get into an aquifer also, like it did in the Southern California aquifer. But remember, we talked about how that's a chaparral habitat, climate, biome, so it's very similar to Mediterranean. That's why they grow grapes and olives and almonds and avocados and stuff there. To do that, they've got to drill down deep and deep into that aquifer, and they've been sucking it dry. They've had 60-minute specials, and I've seen several, read a lot of stuff on it in the last 3 or 4 years. They're having to drill deeper and deeper. Pretty soon that aquifer is going to dry up. So it takes millions of years to fill up with water, and then agricultural can suck it all up in a matter of a few years. And if that happens, they're not going to have any water left. It's really going to hurt the economy. They're not going to be able to use that salt water for that from the ocean, so they're going to be in a lot of trouble. Speaking of saltwater intrusion. That occurs here in Georgia. Draw the state of Georgia again. There's South Carolina. Here's the Atlantic. We have about 6 or 8 counties right along the coast of Georgia. Georgia has about 120 miles of shoreline along the Atlantic. We have about 5 or 6 counties there, another 5 or 6 in. And remember, Georgia has 159 counties. Georgia's the largest state east of the Mississippi, and it's got way too many counties. What happens is you drill a well here. A lot of the big industries, remember, I don't know if it come up that phrase, dilution is the solution to pollution. So most of the big industries that are going to have an effluent, they're going to produce a lot of wastewater. They're going to be on the oceans. They're going to be on big rivers. If you think about it, where are all the big cities located in our country? They're all on a big river. The Great Lakes, the oceans. So a lot of industry down here. Savannah's here, a lot of industry. They drill down deep for wells, they need fresh water for their industry. As they drill here, it pulls the salt water up underneath the land, and the salt comes in and contaminates all the wells. And that's what's happened now. Anybody had a private well in this area, now their well is salty. It doesn't work. They've got to go to a city water, county water or something. That's called saltwater intrusion. When you're near the ocean, you draw up so much fresh water from the ground, from deep reserves, that it sucks in salt from the ocean underneath, and then it contaminates all the wells. And that's happened in Georgia. Okay, next on the list, estuaries and salt marshes versus open oceans. We talked about this on the last lecture, but the estuaries, the shallow, the near shore areas along coastal areas, where sunlight can reach the bottom, is going to be the most productive areas. And these are the nursery grounds for much of the aquatic marine organisms. They come up into the estuaries to have their young, raise their young in the shallower, nutrient-rich water. It's shallow here, so the sun can hit the bottom, right? So we can have food chain. I told you, I think in the last lecture, there's 15 major rivers that flow into the shore. Coast of Georgia. I used to work on a sample at each one of them, right where it came in. And those are all bringing in nutrients that are eroding in from the soil, like I mentioned earlier. So you got lots of nutrients here, shallow water, plenty of sunlight, very productive, lots of food. Very good for nursery grounds for baby fishes and all sorts of things. So very productive areas. We've talked about alternative energy sources. Wouldn't it be nice to make use of the tides twice a day to turn turbines? They're coming in anyway. Huge problem with that is just what I just said. There's so many sensitive organisms in here. How do you suck organisms twice a day in and out without sucking them through those turbines and killing them? We haven't figured out a way to do that yet. But if we do figure out a way, the tides are an easy way to generate power. Okay, saltwater intrusion, estuaries, aquaculture. I like catfish. Later on in the next lecture, we're going to talk about conservation biology, but there's not enough catfish. We eat enough catfish in this county alone here with 200,000 people to drain every catfish from the Chattahoochee. It was all, there used to be a lot, I think I mentioned, there used to be people doing subsistence fishing here in the Chattahoochee. Poor people who didn't have jobs that would spend their days down there fishing so they could get meat for their family. There's not enough fish for their family, protein. There's not enough fish in the Chattahoochee for all of us. There's 10 million people in Georgia, another 5 million in Alabama. All the catfish that you get in the store here, catfish fillets, it's grown in aquaculture. It's farmed in ponds. Auburn University, across the border, is the specialist in that. Auburn is the largest warm water fisheries school in the nation. I think the University of Washington is the largest cold water fisheries, but Auburn University is the university if you want to study fisheries. They developed all the protocols, they developed this aquaculture procedures over there, so all the catfish you get is grown in catfish ponds. All the shrimp you get, if you're not taking the legs off or peeling the carapace off yourself, you're getting it in your Chinese food. It's grown in ponds in China. China grows a lot of the shrimp, and then it's frozen and sent over here. So there's not enough. The bottom line here is, for aquaculture, there's not enough aquatic resources out there to feed all 7.5 billion of us. So we're just like there's not enough. Just like we went to farming a long time ago to get more productive. Same thing with aquaculture. So now we grow these things in like a farm-like situation for our consumption. Over-harvesting, we're going to talk about that later on in another lecture also, but that really happens in aquatic systems. Like for Georgia, there's not a fin fishery left in Georgia, off the coast of Georgia in the Atlantic anymore. There's oysters down there, blue crab, and shrimp, but the other fish, they've been caught out. It's easy to catch them out. Over-harvesting, they have these huge ships. They have these factory ships out west. I guess they still got them. Y'all ever get those little containers full of sardines, cans of sardines and fish steaks? They have these ships that are huge. They do everything from catch the fish to can it right there. When it leaves it, it goes off in cases to the grocery store. Huge ships. And you can imagine they're catching phenomenal amounts of fish in nets. It's easy to over-harvest, especially in fisheries around the world, and that's been done. So it's one of those things called tragedy of the commons. You know, we're based on English law here in this country. In England law, they had the common. It was all the royalty and the peasants. The common lands were for the peasants. They could go out there. The common people could go out there and hunt. They could get their food. They could chop wood. And the idea was, if they know that they catch all the deer, if they kill all the deer and cut all the wood, that they're going to starve to death. But they surely wouldn't do that. But that's what's called the tragedy of the commons. Over and over again in history, we see people that do that. Easter Island's a good example. You know, what were they thinking when they cut down the last tree? If you know the history of Easter Island. So over-harvesting, we tend to do that. We tend to harvest till it's gone. It's a thing of human nature. So it's smart for us to do the aquaculture. Next on our list is wetlands. Wetlands are extremely productive. And think about beaver-created wetlands. A lot of people didn't used to like beaver. Beaver make dams, create an instant wetland, and you have a wetland on your property. I used to get called out in my job for people complaining about the beaver dams on their property. And I'd usually drop what I was doing. I had a whole packet together, and I'd go out there and spend a couple hours with them and tell them how fortunate they were to have beavers on their property. We didn't need to kill them. You're lucky to have them here. And obviously, if you got 3 acres and the beavers dam up all 3 acres, you're in trouble. But I frequently get calls from someone that's got 200 acres and the beaver dammed 2 acres of it, so what? They bring in so much. So you have a stream before that, flowing stream, that's nice, but beaver puts in a dam. Now you've got an entire wetland area there, wetland plants come in, maybe fish come in. You've got thousands of different additional species now, aquatic insects, vertebrates, invertebrates, plants that are now there that weren't there. Wetlands have a lot of functions. Wetlands act as sponges in flood control. The Mississippi River they've drained all the wetlands along it. We'll start up here up in Minnesota, come all the way down to New Orleans. It was about 3 or 4 years ago, they had a real big snow up there, big snow year, and they were predicting flooding all the way down the Mississippi River, and they had it down. They were predicting 2 weeks out St. Louis, 3 weeks out on Memphis. 28 days later, New Orleans was going to flood. You should not be able to predict that. That's what we used to have weirs for. We used to build weirs to do that. That's basically, it's been channelized. What happens is all the wetlands that were here are all gone. The majority of them are gone. They drained all those so people can live there. So normally the floods would come, the water would come out here and sit in the wetlands, act like a sponge, and slowly go back in. Now without these wetlands, the water just rushes down, floods everybody out, and floods all the way down to New Orleans, down to the Gulf.
Once it's gone, it's gone.
What's that?
Once a wetland is gone, it's gone.
Yeah, very hard to get it back. Extremely hard. You have to go back in there by hand to get it back. Put up another dam. Wetlands restoration is actually cutting side branches off of willow trees and planting them in the ground. I mean, it's that intensive. It's so expensive. It's best not to tear it up than to go back in and try to bring it back. Now, flood control is very important. While it's out in wetlands, wetlands seep into the ground. They recharge groundwater. Wetlands are great for silt control. The aquatic plants like cattails that you see in wetlands, at their roots, they can detoxify the most toxic stuff in there. So sometimes you'll see a lot of, when I did the sewage treatment plant earlier, a lot of times you'll see sewage treatment plants with cattails in them and things like that to clean it up. So there's a good half a dozen wonderful uses of wetlands besides bringing in all the wildlife. I'll draw another thing. This was an actual case I worked on. A woman had about 5 or 6 acres, a stream kind of up in the mountains in North Georgia. Stream came around her property like this, flowing this way. Her house was here. Beavers built a dam right here. Unfortunately, upstream we had development. You could see the water was silty here. The water was coming in. It was a beautiful mountain stream. All this got flooded. The dam, so all the water had left here. And now this was all flooded as the water came across. And that's what she was complaining about. She lost her 5 acres. But you could see where the water dropped back into the stream here, it was crystal clear again. As all the silt, as it went across here, the silt fell out. So silt control helps, detoxifying, flood control, just wonderful uses of wetlands. People up through the 1970s in this country, people thought wetlands were bad. They were trying to drain them. You could buy them cheap. It used to be improved pasture was the most expensive, then hardwood forest, pine forest, all the way down to wetlands. You could get it dirt cheap, and people couldn't do anything with it. Now it's the most expensive. People realize that they got it, they can lease it out to duck hunters or something like that. So you're very fortunate if you have a wetland now. Wetlands are very productive areas. Like I say, very fortunate. Beavers next on the list. Again, beaver created wetlands. They dam up, create a wetland. It's amazing. Beaver are known as a keystone species. Keystone species is a species due to its activities has a positive effect on a large amount of other species. Think about it. You got a little stream going through there. A beaver dams it up now, and then you're all the way up. You've got thousands of new species in there now. Okay, finishing up, getting close. Rainwater, next on our list. I mentioned this, I think, already, but I used to notice how with my gardens, when through the summer when it didn't rain and I watered them out of my well, they kept alive, but they didn't grow. Then a week or two later, I'd get a natural thunderstorm here, and I noticed my plants would shoot up, my tomatoes, everything would shoot up 6 inches or something. Oh, it seemed like within a few days. So I knew there was something in rainwater that wasn't in regular water. Now you've probably always heard that lightning creates nitrogen in the atmosphere. But what actually happens is nitrogen in the atmosphere is in the form of nitrogen gas. N2, that is two nitrogens bonded together. Lightning up there, it's not just the lightning coming down this way. There's electrical storms. There's so much electricity out there right now, it's raining. Going up zigzags, all sorts of electricity. It splits these nitrogens into independent nitrogens. And nitrogen gas is in the form of N2, two nitrogens bonded together. These independent nitrogens are very unstable. They don't like to be by themselves. They bond with something else. They bind with the oxygen in the atmosphere to create NO3. NO3 is nitrates. That's fertilizer. So when we have electrical storms here in the south, which almost every storm in the summer is going to be an electrical storm, a thunderstorm, it's raining nitrates on your garden. You notice how everything gets real green and your grass gets green after a nice natural rain? That's because, again, the lightning, all the electrical charges in the atmosphere are splitting the nitrogen gas into independent nitrogens, which are unsteady. They bond with the oxygen in the air to create nitrates, and it's actually raining nitrates, fertilizer, on your garden. Okay, last on the list, again, I just wanted to cover some things that your book doesn't cover, some general things we can all relate to, is bottled water. Anybody here buy bottled water? Like bottled water? Do you really believe it comes out of a spring in the ground that's cleaner than anywhere else?
Nope.
I've seen expose after expose on 60 Minutes, 2020, whatever. No. They don't just pull it out of the air, but they pull it out of like a well like mine. Maybe they put it through a little filtration, and they put a nice Callaway Blue, that's a company out in my area, that sells a lot of water, and they put some nice spring on there. You've heard of Poland Springs. I guarantee you that water doesn't come out of a spring called Poland. And again, think about this. I'm always looking for get-rich-quick schemes, but we missed this one. 30 years ago, 25 years ago, if you told someone you were going to sell them a bottle of water, they'd have locked you up. It's a multi-billion-dollar industry now. I think Coca-Cola and Pepsi probably sell more bottled water than they do their carbonated product, their Coca-Cola and Pepsi products. It's expensive. If you like it, it's okay, but it's really not much better than what's out of the faucet here. Maybe slightly better, but if you can get it cheap enough, I don't know. But I think the next thing we'll try to figure out is since we missed that get-rich-quick scheme, if I can figure out how to sell oxygen to atmosphere to you guys. Because think about it, water was cheap and free. It was the one thing that was always free and cheap, at least for us in America, right? I stopped at a convenience store a couple of years ago. They had just opened up, so they had all their computer stuff, and they told me that their water was more expensive than beer. By the time you buy your water. So bottled water, it's not unclean. It's not what they say it is generally. It's not super filtered, super out of some super clean spring out of the mountains of Vermont or North Georgia or some pristine area. They're taking mostly well water and then purifying it, putting it in a nice container where you think it's clean, and then selling it to you. Now, real quickly, one last thing. I meant to mention this earlier. In Georgia, I'll draw Georgia again. We mentioned the fall line. The fall line goes from Columbus through Macon to Augusta. Savannah's down here. On the northern part of the state, north of the fall line, drinking water comes from surface waters, like we have here. We're taking our water right here out of the Chattahoochee. There's an intake right near the Oliver Dam here. It's surface water, so yeah, it has fish pee in it and whatever else is in there. Below the fall line, they take their water out of deep wells. When I worked in Albany during the floods back in 1994, they had 5 deep wells that supplied the whole 100,000 people down there. So north of the fall line, we get our drinking water, municipal drinking water from surface waters. South of the fall line is from wells, which would be, I would think, be cleaner. Just coming out of a well. Alrighty. Well, I think that will conclude our water lecture for tonight. I'm not sure how long that took. Any questions? Comments? Concerns? Well, that should do it then.